So here I have taken a buck converter. So all the data are given here. This input voltage is 15 volt and output on resistance is given. So the power of the resistance is given as 250. Load power is 250. So here these things, all things we have to calculate. First, like one by one we will go. What will be the average voltage? This is the switch pulse of switching logic for the this switch. Here it is a switch S1. So this is that one cycle 6 microsecond and on time how much? 4 microsecond. So can anyone tell what will be the output voltage here? It's very simple. What will be the output voltage?
What?
See, this is the gate pulse to switch S1. This is buck converter. So S1 we are turning on for 4 microsecond. After that it will turn off till 6 microsecond. So total time period is 6 microsecond and on time is the 4 microsecond. Okay. So what will be the average voltage here? Input voltage is given as 15 volt. Input voltage is 15 volt. So in buck converter which formula we will use? What will be the output voltage formula? It's very simple. Can anyone reply? See, VO is equal to DVS. This all of you know, I think. Is it clear? D is the duty. Duty means on time divided by total time. So what will be the duty here? Duty will be 4 by 6. 4 for 4 microsecond switch is on and total time period is 6 microseconds. So duty is 4 by 6. 4 by 6 into VS 15. How much can anyone calculate? So this will be 2 by 3. It will be 10.
10.
10 volt. So output average voltage will be 10 volt. Okay. And one thing is written in the question that the C is very large. So output voltage will not have any ripple. So what will be the average output current? I naught. Power we have already. So power equation we can apply. PO is equal to V naught I naught. So from here we can calculate I naught. What will be the value of I naught? V naught divided by V naught. So it will be 25 ampere. Get clear? Okay.
Sir, what is power?
Power is 250 watt. Already
Okay,
resistive load is
250.
given. 250 watt power is given here. So I naught will be P naught divided by V naught. This will be 25 amps. Okay.
Sir, average current in a capacitor will be zero, right?
Here average current will be zero. So one by one I am going to draw the waveforms. Okay. One second. First I will add some pages. Okay. So we can analyze the waveforms like output voltage, current is already constant we know. So what will be the inductor average current? Can anyone tell? IL average? It will be the same. See here average current is zero. So what will be the average current in the load? That will be the average current of the inductor. So inductor voltage waveform you can draw. Second. Inductor current will be the triangular waveform. Okay. Some maximum value will be there and some minimum value will be there. So it will charge like this one for on duration and it will discharge IL max and IL minimum. And what will be the middle value? Middle value will be the IL average. This value only will be the I naught average. So how much it will be? 25 amps. Okay. Now we can calculate this ripple value. This ripple we can calculate. This is the delta IL. Okay. So how we can calculate this ripple? This is the on time. This is the on time T on. And this is off time T off. And here up to here it is total time period. So this formula we can apply. VL is equal to L into di by dt. So di by dt, what it will be? Di by dt is equal to VL by L. Okay. So coming to the circuit, this is the VL, here plus and here minus. So during on duration, what will be this voltage? This voltage will be Vs minus V naught. When this switch will be on, this voltage will be Vs minus V naught. Okay. So from this waveform, we can observe that what will be this di by dt. So di by dt, from this slope we can write here. See, di means I2 minus I1. This is I2, this is I1. Okay, IL max minus IL minimum, which we are calling as delta IL. So delta IL, this is Y2 minus Y1. What is X2 minus X1? X point is this one, X2 minus X1. So this will be T on is equal to VL. So what is VL? VL is equal to Vs minus V naught by L. Is this equation is clear to all? Otherwise, I will explain again.
Sir, please again.
Okay, see. In buck converter, inductor current continuous conduction, inductor current waveform will be like this one. Okay. It has some maximum value and some minimum value. And what will be the middle value? Middle value will be the average value of this inductor current. Okay. So see here, already we have calculated the output current. So capacitor average current will be zero. So this average current will be equal to inductor average current. Okay. So here middle point what I am writing inductor average current. This will be the minimum value. This will be the maximum value. So from here to here, this switch is on. Switch S1 is on. So S1 is on means what will be this VL? Here this plus and this minus. This is VL. The VL value we can see that here VS will, so it will be input minus output. So here to here, switch is on and VL is Vs minus V naught. So this equation I am applying. VL is equal to L di by dt. So di by dt is equal to VL by L. During on duration, what will be the value of VL? It will be Vs minus V naught. Okay. So from here we can calculate the slope of this line. Okay, di by dt means what? I2 minus I1 divided by T2 minus T1. So I2 minus I1, I2 means IL maximum, I1 is IL minimum. So I2 minus I1 will be delta IL and X2 minus X1. X2 minus X1 will be from here. This is X2 and this is X1. X2 minus X1 will be T on. So this equation we can derive. Okay, di by dt means slope. During this on period, slope will be this one and VL is Vs minus V naught. So from here we can calculate this delta IL value. Is it clear now?
Yes, sir. Sir, I have one question
Okay.
for you.
Okay, okay,
That
okay.
is, in inductor, the minimum value, why not it's zero, only
Okay,
on zero?
okay, okay. See, if it will work in continuous conduction mode, okay. Minimum value means it can work in discontinuous mode also. So if this average value, see how we can say that it is continuous or discontinuous. So if this average value, see this is the boundary condition, means charging, this is one cycle, charging up to here and discharging just here. Okay. If it is discharging before this point, then it will called as discontinuous, means here to here inductor current will be zero. But in continuous conduction mode, it will be in up only. Like it will start charging like this from starting and it will settle to some maximum and minimum. Okay. So this is the case for like continuous conduction. Discontinuous also happens, depends on load and inductor value. Okay. So when we can say that this is like boundary of continuous and discontinuous. So some case we can select. Let's say this is the inductor current. This is the total time period, and here T on. Okay, and this is the I not I average. Okay, so when this value will be half of this delta IL, that case we can say that the converter is running in the boundary of continuous and discontinuous conduction. Okay, when this IL average, okay, is greater than delta IL by 2, this is the case for which we can say that the converter is working in continuous conduction mode. Okay,
Okay,
so
sir.
so I'm going to calculate the delta IL value. Here we can see that whether it will be continuous or discontinuous. So already this I naught is how much? 25 ampere, this average value. So delta IL we can calculate from this one. So delta IL is equal to how much? Vs minus V naught will be 15 minus 10. It will be 5. 5 divided by L already 5 micro Henry into this T on is 4 micro. This only. So delta IL will be 4. Okay. Ripple current will be 4. So we can see that IL already, or IL average how much? 25, greater than 4 by 2. So we can say that our converter is working in continuous conduction mode. Okay. Is it clear? See, ripple current we have calculated. So ripple from here to here value we are getting as 4. So if average value will be 2, see, if average value will be 2, as if load will be such that the average value will be 2, this is 2 ampere. So we can say that according to this ripple, this will be at boundary of continuous and discontinuous conduction. Okay, but here we are seeing that our average current itself is 25 ampere and ripple we are getting 2 ampere. So how will be the waveform? Waveform will be settled across this 25 ampere line. So this is the 25 ampere line, and plus 2 minus 2 ripple will be there in inductor current. Okay, so here how much we can say maximum value, can anyone tell how much it will be? Just 25 plus 2. So here it will be 27. Okay. And here 25 minus 2, how much it will be? 23.
23.
Okay. So minimum and maximum value. So how we are deciding this is continuous or discontinuous? This delta IL we are calculating, and this average current. This average current is half of this. If it is more than half of this, so we can say that it is continuous conduction. If it will be just equal to half, then boundary of continuous and discontinuous. Is it clear? Okay.
Sir, no, sir. Sir, what means continuous and discontinuous?
See, this is ripple current, delta IL. Okay. So if it will be at
Okay.
boundary of continuous and discontinuous, the waveform will touch the zero axis. Like this is the inductor current, it will touch the zero axis. This is charging time T on, and it will discharge in total time. Okay. So this is the average value, average of this current. So if this delta IL by 2, this is delta IL by 2, if it will be equal to this average current, then we can say that this is just boundary of continuous and discontinuous conduction. Is it clear?
Okay. Okay.
So it will, like, let's say this average current is 2 ampere. Okay. So we can say that this delta IL is 4, from here to here it is 4, and delta IL by 2 is 2. So we can say that if the load current will be 2 ampere, it means that we can say that this will work at boundary of continuous and discontinuous conduction. Okay. If load current is, if average current itself is too high, means 25 ampere. So 25 ampere plus ripple, it will go 27 and 23. Is it clear?
Yes,
Okay.
sir. And sir,
Yes.
if it is boundary of continuous and discontinuous, then what will happen?
See, it will be continuous only, but just it is a condition. Like after this, if we are changing some inductor or resistance value, then it will, like, let's say we are decreasing the value of inductor. Okay. We are decreasing the value of inductor, so it will come here like that. So here current will be zero. That will be different kind of analysis. That will be discontinuous conduction analysis. Analysis will be different in that kind case. Okay.
Okay. Means, sir, this time period will reduce.
Yes, and this normal formula also will not work. Like VO is equal to dV we are applying. This formula will not work in case of discontinuous conduction. This is only valid for the continuous conduction. Okay. So how we are checking the continuous or discontinuous? First we are calculating the ripple current. Okay. And ripple current divided by 2. So IL average. IL average, what is IL average? Is equal to I naught average. Okay. If this value is greater than delta IL by 2, we can say that converter is working in continuous conduction mode. If it will be just equal, then this condition we realize, and we can say that this is a boundary of continuous and discontinuous. Is it clear? Okay.
Yes, sir.
Okay. So one by one we will solve all the part. So what I have asked, we can see first here. See, I naught average we have calculated, maximum minimum we have calculated. What will be the value of IL average? So that is I naught average. What will be the value of IL RMS? So IL RMS, how we can calculate? Already formula I have told. Okay. So that I'm going to calculate here. See, what formula I have told? RMS is equal to under
Under
root
root
U
U
into D. So here,
D.
see, this is the big triangle from here to here. Okay. So what will be the duty for this big triangle? Duty will be 1, because it is available for total time period. Duty you found as 1. So what will be the value? It will be 1 by 3 into 23 square plus 27 square plus 23 into 27. This will be the in duty will be 1. So what will be the RMS value of this inductor current? Can anyone tell? So 1 second. Already I have calculated this one. I will write 25.02 or something. 25.02 amps. So this type of question can be asked, like in GATE, if this will be asked, you can directly draw the waveform minimum and maximum value, and you can calculate the RMS value with this formula. In 2 marks also it can be asked.
Okay, and sir, you
20.
did take this time period T only, and this waveform will go
See,
ahead
see
also.
which one? So this is the time period.
Yes, sir.
So this is a triangular wave. Already I told you like this formula. So what is the duty of this triangular wave? Duty of this triangular wave is total D is equal to 1. Otherwise, you can do in part wise, two part we can say from this part and this part. So for this part, duty is 0.4, okay, and for this part, duty is 0.6. So 0.4 plus 0.6 will be 1 only. Is it clear?
Okay.
In part wise also you can do. I already told now, like you can divide the waveform into two parts or three parts. So this is one part, this is one part, okay. Duty for this part how much? 0.4. No, how much? We can calculate. We have like 4 by 6, na? How much? So this will be 2 by 3. See, duty will be here for this waveform 2 by 3. This will be 1 minus 2 by 3. Okay. If we will add this 2, we will get 1. That's why big triangle, how much duty? Duty is 1. Okay. Is it clear?
Yes, sir.
Okay.
So both have I think it's same.
Can you ask again?
T on and T
Off. See, T on
off.
is here. See, T
Both.
on is 4 micro. So what will be the duty for T on? Duty for T on will be 4 by 6.
Okay, sir. Okay, sir. Okay, sir.
And here it will be 1 minus 4 by 6.
Okay, sir.
Okay. Okay.
Sir, in question, the switch only on for 4 seconds.
Okay. Yes. It is on for 4 seconds. Off for remaining duration. So one cycle is 6 microsecond. From here to here 6. From here to here 4. So it is off for 2 microsecond duration. Okay. Okay.
Yes, sir.
So this will be 25.02. Is it clear this RMS value calculation? Already I have explained this concept. Like this is a big time for all triangle. This is the formula 1 by 3 b1 square plus b2 square plus b1 b2. So we can directly consider this big triangle. Instead of two small triangles, we can directly consider this big triangle. Small triangles also if we will consider, this u value will be same. Okay. U value will be same and d1 plus d2 will come as 1. So same way I am considering this big triangle. So big triangle U will be same only. What is the RMS value? U into D 25.02 ampere. Is it clear? Okay.
Yes, sir.
Further, so another question is what will be the value of capacitor RMS current? This is what will be the value of capacitor RMS current. So here we can see that what is the IC? IC is equal to IL minus I naught. At this node we can see that what is IC? IC is equal to IL minus I naught. So here we can draw the waveform of the IC. So 1 second.
Sir, we required these notes, I think.
Okay, okay. Oh, 1 second. I will do on the next page. Is it clear? Okay. I'll add more page. Okay. Here I will write. So on second I will write that. So this is the inductor current. This is T on and this is T off. This is IL average. This will follow this path. Okay. And IC current will be here. So IC is equal to IL minus I naught. Okay. IC is equal, this is IL and this is I naught. I'm going to draw the IC. So here it will be this. This is how much peak? 27 and minimum is 23. This is 27 and minimum is 23. What is the average value? 25. Okay. So we have to subtract this IL minus this I naught. Okay. So at this point it will cross this one. Okay. What will be the value here? This is 25 minus IL 23 minus 25. So it will start from minus 2. Okay. Minus 2 it will go up to here. Here it will be 27 minus 25. So it will be 2. And here it will be 2 1 minus 2. So this is the capacitor current for one cycle. Now we have to calculate the value of this RMS current. So this is 2, this is minus 2. Okay. So it's easy only. Already I have told the trick. With that trick only you have to calculate the RMS value. This is one period waveform we already have. So what will be the final RMS value of this capacitor currents? I will give you 1 minute of time. 1 minute is more than sufficient to solve this. So after that I will explain. IC RMS value you have to calculate. Okay. So I will wait for 1 minute. Till then you can try what will be the IC RMS value. This highest value is 2. This is minus 2. And here this section is 0. This will be 0.5. And here this section will be 0.25. And this section will be 0.25. Because it will be symmetrical. So mid section will be 0.5. Here it will be 0.25. Here it will be 0.25.
2 by under root 3.
2 by under root 3. How we have calculated?
Sir, under root 1 by 3 into 2 by plus 2, the formula.
Okay. 1 second. I think this values I think I have written wrong here. See, this will be here to here. It will be 0 up to 4. So 2 by 3. Charging period will be more only here. This will be more only and this will be less, I think. But this minimum and maximum value will be same. Okay. So overall, this three duty will be there. We no need to think like this is D1. Let's say anything. It will be D1. This is D2 and this is D3. Okay. And already I have told you what is the value of this U. U will be VSR by 3. Okay. So RMS we can calculate like this. These are three triangular waveform. What is the amplitude? Amplitude is the 2. So D1 plus D2 plus D3 will be 1. So we can write this V square by 3 into D1 plus V square by 3 into, no, this is I. So I is 2. 2 square by 3 into D1 plus 2 square by 3 into D2 plus
So
2
we are
square by
getting
3
2,
into
sir.
D3. See. So it will be 2 by root 3. Final answer will be 2 by root 3. Is it clear? I will explain again how we are getting. So here we have three triangle. Okay. Here we have three triangle. This is one triangle. This is another triangle. And this is below one triangle. What is the magnitude of the triangle in all case? This is 2. This is also minus 2. Here also minus 2. Okay. So this value will be like how much this is charging time. So 2 by 3. This duty will be 2 by 3. And this will be from here to here it will be 1 minus 2 by 3. Okay, this both section will not be equal, but here in capacitor current if we are seeing this D1 plus D2 plus D3 it should be equal to 1. D1 plus D2 plus D3 is equal to 1. So these three triangles, different triangle. Okay, so what is the U for any triangle? It is V square by 3. So V square by 3 means minus 2 square by 3 into D1 plus this second triangle also 2 square by 3 into D2, third triangle 2 square by 3 into D3. Okay. So 2 by root 3 will be common and D1 plus D2 plus D3 will be 1. So final answer will be 2 by under root 3.
Sir,
Get
here we are getting only 2, sir.
how?
Here 2 square 4, sir. 2 square 4, 2 square 4, sir. Like that
Okay.
we get 12 by 3, 4. Under root 4 we get 2 now, sir.
See 2 square by 3 will be common. 2 square by 3 will be common and what D1 plus D2 plus D3 is equal to 1. Okay. And this will be the
3
total.
is
So final will be 2 by root 3. Is it clear?
okay, sir.
This all part will be common. 2 square by c. See this d1 I have written here 0.25, but it will not be 0.25. Okay, because here we can see that from this waveform like charging time will be more. Here to here charging time and here to here a small discharging time. So 50% of this one will come here and 50% of this one will come here. But overall D1 plus D2 plus D3 will be 1. So no need to care about D1, what will be D1, what will be D2 and what will be D3. Directly we can write like this one. So this will be ICRMS. Is it
Sir,
clear
for
to you?
this we can't use like previous formula, sir.
Previous one,
Uh,
see this is okay. Previous formula
1
you
by
are
3 into
okay,
sir.
that is for okay, that also we can try. Okay,
Sir, if you use the previous formula, then answer
it should come
is the same.
same na, it will be same only.
Yeah.
See it will be same only. So minus 2 and 2, that both formula will same only. Like this is the this formula triangle means if value will be 0. See for triangle what will be the value, how this u I have derived, this is 0, this is v. So 1 by 3 into 0 square plus v square plus 0 into v 0. So what will be the value, b square by 3. So that both formula are same. This triangle formula derived from that only. Okay.
Okay.
So with that one also
Sir,
directly, yes, that will be better. Like directly we can apply that formula. So 1 by 3 into minus 2 square plus 2 square plus how much? 2
Minus two in minus two into two.
so it will be minus 4. Okay.
Minus four.
So it will be under root 4 by 3 equal to 2 by root 3. Get clear? So both formula we are getting the same answer. It's a good way. Like directly we can apply the big triangle formula. Good.
sir, I didn't do. I get this D1 plus D2 plus D3 is equal to 1. How?
See, D1 means total time period, na? Let's say total time period. So duty for total time period will be 1. See how we can say that. Let's say I will explain with an example. Let's say
Sir,
I'll
here
yes.
the total waveform T is equal to 1. Total waveform
Yes. So that's
from
right. Total duty will be means D1 a small duty D1, this D2 and this D3 should be equal to 1.
yes, sir. There are four part symmetrical. That means the D2 here is zero point 0.5
No, no,
and another
middle will be zero point 0.5 and this
yes.
will be somewhat different. This will be different and this will be different. This
Okay,
will
sir.
not be 0.25 like that
Okay.
we can I can try. So see, first part is 2 by 3. This is 2 by 3. And this second part is 1 minus 2 by 3 means 1 by 3. Okay. So how will be the inductor current? This will be inductor current will be like this one. Okay. It will go from here to here, from here to here. Okay. So this is the mid part. So this section is half of 2 by 3 and this section is half of 1 by 3. Okay. So this will be 1 by 3. This will be 1 by 3 and this will be 1 by 6. This will be 1 by 6. Now is it clear?
Yes, sir. Yes, sir. Yeah.
So according to this you can write. Okay, one person has doubt in how D1 plus D2 plus D3 is equal to 1. Is it clear or again I have to explain that? Should I explain or is it clear? D1 plus D2 plus D3 equal to 1.
Yes, sir. And sir, why you divide by 3?
Where? Which one? This formula. This one.
No, no. Now you did write 1 by 3, 1 by 6, like.
Okay, okay, 1 second. Again, I will write. Say inductor. This is the inductor voltage. Okay, this is on time. This is total time period. Okay, so on time, how much? 2 by 3 duty. And this is duty how much? 1 by 3. Here we can see that hmm, this is 4. So 4 by 6, 2 by 3. So duty for this on time will be, this will be 2 by 3, this will be 1 by 3. So how will be the inductor current waveform? Here I have drawn, this is not correct. Like charging and discharging time should not be equal, because charging time for 2 by 3 duration and discharging for 1 by 3. So inductor current, if I write going to draw, so it will be come at here T on, so it will go from here to here. This will be large, and here this is on time, so it will be a small. This is discharging. Okay, so here to here how much? 2 by 3, and here to here how much? 1 by 3. So if I am going to draw this middle line, okay, this average current, so middle at where it will come? This will be half. So 2 by 3 half, how much will be? 1 by 3. This divided by 2. Here this, from here to here it will be 1 by 3. Here to here it will be 1 by 3. If 1 by 3 will divide by 2, how much it will be? So it will be 1 by 6. Here also it will be 1 by 6. Okay, this I have written. So here this D1 should be how much? D1 should be 1 by 3. Okay, D2 should be 0.5 and D3 should be 1 by 6. Now is it clear?
Yes, sir.
Okay. So now I will explain how to, this is the main concept for today class, like it will be more interesting. So here we have to calculate these two input resistance. One is at here before source, this input resistance here. What will be the input resistance seen by this voltage source? And here again at this point, what will be the input resistance seen by at this point? Here plus and here minus. What will be the input resistance seen here? So these two resistance we have to calculate. Okay. So actually in last class what I have told, like RMS value we have to take, but RMS value we should not consider. I will explain why. So see, like 1 second. So if like this is the average power formula for any two waveform will be given, what will be the average power? P average is equal to 1 by T. This is VT, IT, DT. This voltage function, current function into DT. This everyone knows this formula, basic average power formula. Is it clear? Okay. So see here, this voltage is constant. Okay, input voltage is constant. So if voltage will be constant, if any function will be constant, how we can write average formula? We can write is equal to that constant we can take common. So let's say voltage is constant, voltage or current, anything, say voltage constant, so voltage I'm taking common. Constant thing we can take common. So V into 1 by T integral I dt. Okay. So if out of V or I, any one will be common, what will be the average power? Average power will be average of the, like whatever we are taking common, another thing, this is what we can call average of the current. Okay. So what will be the average power? Average power is equal to V into I average. This will be the average power. Is it clear? Hello?
Yes,
Okay.
sir.
Yes, yes, sir.
Okay, so same converter, like let's say this is Vs. So Vs, how much resistance it will see? This is the source voltage in converter. So we are just going to see equivalent resistance, R equivalent, how much it will see. Okay, so what is the power delivered by the source? Power delivered by the source is V, the source voltage into average current, this average current. Okay, so same thing we can write as V square by R equivalent. Okay, like one power we can write as power delivered by the source, how much? V into I average, this I average. Okay, same power for equivalent resistance we can write as V square by R. Okay, so from here we can see that what will be the value of R equivalent? R equivalent will be Vs by I average. Okay, so when y I average, because here we are seeing that while equating this equation, we can get that R equivalent will be should be equal to Vs by I average. Is it clear? So just we
Sir, power is equal to V into IRMS, no?
see why here coming to here this how much this current will be there na, this current. Okay, so V into I average will be the input power. Why V into I average? That I will explain you here. This is the average power formula. V average is equal to 1 by T V I dt. Okay. So this formula, since source voltage is constant, so constant thing we can take common. So what I have done, V I have taken as common. So common means what will be the another term? 1 by T into I dt. So this formula what we will say 1 by T I dt means average of the current. Okay. So what will be the power? Like DC buck converter input power will be V source into I average. Why I average? See, this is the basic formula. In this formula, any waveform we can apply, we will get the average power. So here I have taken the V common. Why V common I have taken? Because taken out because this is the constant value. So constant value we can take outside. Okay. What is the remaining term? Remaining term 1 by T I dt. So this will be I average. Any average, what is the formula? 1 by T 0 to T ft dt. This is called as average. Okay. That's why what will be the average power? Average power will be V into I average. Is it clear? Why not RMS? Why
Okay.
average? Because you see,
Okay, sir.
anywhere, see, I'm telling you one concept. Anywhere, if two quantities will be there, voltage and current, okay. Out of that, if one will be constant, what will be the average power? Another average we will take. Let's say if current also will be constant, here we will say I into V average. If current will be constant, current we will take common, so it will be I into V average, power will be. So what concept you have to apply? If any quantity will be constant, that we will take common outside and another value will be the average value. Is it clear?
Yes, sir. We are
Oh,
calculating here average power.
average power means this is the average power formula. Let's see. So the same thing we have to represent in term of a resistance. So that voltage source should supply same amount of power. So for input in resistance I am assuming as R equivalent. So what will be the power delivered by the source? This will be Vs square by R equivalent. So for DC, what will be the RMS or average? Both will be same or constant value. So this Vs square by R equivalent should be equal to same this power Vs into I average. Okay. So what will be the final value? R equivalent will be Vs by I average. Okay. Is it clear? So what will
Yes, sir.
what will be the IS average value? Anyone? IS average, source current average. So see, this switch will on means source will conduct. When switch will be off, this diode will conduct. Okay. And Vs IS average we can calculate with power balance equation also. So that we can apply here. One second. So Vs IS is equal to V naught I naught. Vs IS is equal to V naught I naught. Can anyone tell what will be the IS value from here? So V naught I naught how much? 250. And Vs is how much? 15. How much is the IS?
Sir, 16.6.
16.66. Okay, so from here we can calculate IS. We already know the value, so we can calculate. Another directly how we can calculate since output power is given. Okay, so what will be the R equivalent? Can anyone tell? What will be the value in this case? What will be the input resistance? P is equal to V square by R. Okay, we know. So R will be P by V square. P how much?
Sir, point 0.6.
Point
0.6 ohm.
0.6. So 0.6 ohm. R input will be 0.6 ohm. So in any converter, if before switch, if it will be asked, see before switch means source voltage is constant. So one thing is constant means this formula we have to apply. R equivalent is equal to Vs divided by I average. Why I already have derived here. Okay, everything I have written. Why it is average. Okay. So directly we can no need to do this V by I average since power is known. So same power should be supplied by this source. So power is equal to V square by R. R will be 250 divided by 15 square. Okay. So this will be 0.6, I think. Is it clear? Directly we can calculate P by V square. V square by P. I think V square by P. I think I have written here. R is equal to V square by P. Here R will be equal to V square by P. So V is how much? 15. 15 square by P. 15 square divided by 250. How much? Oh, no, I think it's 0.9 or 0.6. Can anyone clarify?
Say 0.9.
It will be 0.9, na? Final answer will be 0.9. From here also we can see. 1 second, I have not calculated. So see the high average 250 divided by 15. So 250 divided by 15. How much? 50 by 3, 16.66. Okay. So 16.66. How much we have to divide in 15? So inverse will take into 15. 0.9. It will be 0.9 ohm. Everyone is getting same. It's same from both formula.
Yes,
Like
sir. 0.9.
Vs by I average, or directly we can do P is equal to V square by R. So how much is the load power is delivering? This equivalent circuit will deliver the same amount of power. So V square by R is equal to V square by P is equal to 0.9. Okay. So now I am coming to the next case, like when we have to use the RMS value. Okay. So see here, this I have to calculate. So when both the voltage and current will be variable, okay, when both the voltage and current will be variable, then this case will arise. Okay. So see here I have one simple circuit I have taken. This is the voltage source and this is the resistance, simple resistance. So what will be the like I am giving a square wave here. What is the amplitude? V, and current amplitude will be same. So 0.5 is the duty of the both voltage and current. So since this voltage is present for 0.2 0.5, so current also will be present for 0.5. So this is the waveform of the voltage and current. Okay. So what will be the average power? Average power will be 1 by T into Vt It dt. So this will be 1 by T 0 to 0.5 T Vi dt. So here we can see that what is the average power? 0.5 Vi. And if we are multiplying the RMS value of this two quantity. So first quantity RMS value how much? 0.5 under root into V. And how much is the current RMS value? 0.5 under root into I. So we can see that if both quantity will be variable, what we are doing, we have to multiply both RMS value. Okay. If one quantity will be constant, that we will take common. So average value we have to multiply for other value. But if voltage and current will be variable, in that case, what will be the power? Power is equal to VRMS into IRMS. Is it clear? See, this is the fundamental average power formula. This I am only applying everywhere. But if one value will be constant, what we have to take? That will be outside, means other value we have to take the average. If both value are variable, okay, in that case, what we are observing? For power, we have to multiply VRMS into IRMS. Is it clear? Is it clear to all?
As a variable means they are
See
the function of time.
yes. So see here voltage also. If you see the voltage waveform, this is available for 0.5 duty. This is a periodic voltage. Again, it will start from here. Okay. So this voltage present across this resistance. So current waveform also will be same. It is like this one. It is also available for 0.5 duty, and this is the total time period. Again, it will start from here. So these both are function of time. Okay. If it will be constant for whole duration, then we can take as common, and other value in that case, we can take average and multiply. But here both voltage and current are variable with respect to time. So in this case, what we are observing? We are observing that whatever this formula I have calculated the average value. So how I am getting that average power? By multiplying the RMS value of these two signals. RMS value of first voltage signal will be under root 0.5 V. RMS of the current will be under root 0.5 into I. So final multiplying, we are getting the same. That means this average formula is verified. Is it clear? It clear to all?
Sir, what you said, average formula is verified.
See, this is the fundamental average formula. You have studied in signal system also. What is the average power of any signal? See, voltage and current, two signal will be there. What will be the instantaneous power? Instantaneous power will be Vt into It. Okay.
Yes, sir.
What is the average value of any signal? 1 by t into function of t into dt. So these two
Yes.
instantaneous value we are multiplying. So this will be the average power formula for any signal. Okay. So this only I am taking. If one will be common, so what we have observed, like if voltage is common means voltage I have taken out means it will be another factor will be average of the current. So what I have written V into I average. But here what we are observing, both are variable. So I have calculated the power as per this formula. This period is 0.0 to 0.5 t. So this is 0.5 into VI, final average power. So I'm multiplying the RMS value of these two signal. I'm getting the same. It means what is the conclusion? Like if both signal will be variable, then the power will be VF RMS into IF RMS. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Sir, and sir, in power electronic there are multiple case of one topic.
Which one?
Sir, in power electronic there are multiple case of one topic. Like this is a converter. There are alternate case of this topic also.
Yes, yes, yes. I will cover. One second. So like here I have drawn the. This is the source current. Source current. Okay. And so what will be the voltage here? First I will go here. So here voltage will be not constant, it will be a periodic voltage from here to here. This is V1, okay, and this is I1. So I1 when it will present, when this source will conduct, then I1 money will conduct, so it will conduct for duty, and next cycle this diode will conduct. So this voltage will be variable here. What will be the voltage? For on time it will be present, off time this diode will be sorted, so voltage here will be 0. Okay, so same thing I have written here. This is the voltage. Okay, so 15 will present for 2 by 3 duty, and for remaining what it will be 0. Okay, this is total time period. This is total time period. So this will be 23 and this will be 27. So this is the current I1 at that point. Okay, this was the switch, and after this diode was there, and here this will be the voltage across this one, and this will be the current across this one. Is it clear? This voltage and current waveform. Can anyone tell?
Okay. Yes, sir.
So see, in case of this kind of waveform, what will be the input resistance? So see, P is equal to VRMS into IRMS should be equal to, if equivalent circuit I am telling, so it will should be equal to VRMS whole square by R. Since this is a variable voltage, so power will be VRMS whole square by R. So what will be the input resistance? In this kind of case, input resistance will be V input RMS divided by I RMS. Okay, what will be the current there? That RMS value we will take. So if both will be variable, we will take that case. Okay. So what will be the RMS value of this one? Both signal. Can anyone tell? Both signals. So here 2 by 3. So we can calculate IRMS. Second. IRMS is equal to 1 by 3, 23 square plus 27 square plus 23 into 27. Okay, into duty how much? 2 by 3. So this value how much? I think already
Yes, sir.
have.
For same signal.
So it will be 20.43 ampere. This RMS value. Here before switch one current will be there, and here one voltage will be there. So what will be the RMS value of this voltage? Voltage RMS will be 15 into under root 2 by 3. Okay. So final resistance will be RIN will be 15 into root 2 by 3 divided by 20.43. So this will be approx 0.6, I think. Same thing we can calculate by power equation. So P is equal to V square by R. Okay, R is equal to P by V square. So see here we have to, every place we have to take RMS value since both the waveforms are variable. So what will be the power? 250 divided by this RMS value 15 into root 2 by 3 whole square. Can you calculate this one?
I
So
think, sir, this is wrong.
how?
V square by P, na? R is equal to V square by P.
Okay. Mistake I have done. 1 second. This time you can point it out. So R is equal to 15 into root 2 by 3 whole square divided by power how much? 250. This will be 0.61. See, so this thing we have to clarify where to take RMS and where to take average. Okay. So in first case, why we have taken RMS current? Because one voltage source was continuous, and if here what we are observing at across the diode, that voltage is also variable and current is also variable. So in that case, we have to take the RMS value of this two. Okay. So this we will get as 0.6 ohm. 0.6 is correct. Everyone have calculated this one.
Sir, I got 0.2, 0.2.
1 second, I will also calculate once. 15 into root 2 by 3 whole total whole square. 15 into under root 2 by 3 whole 1 second. Total whole square divided by 250. It will become as 3 by 5. It will come as 3 by 5 means 0.6. Anyone got this answer? 15 into root 2 by 3. See this RMS, this current is present for how much? 2 by 3. So what is the RMS value? RMS for this one is equal to 15 square into 2 by 3 U into D.
Sir, 0.6 only, sir.
0.6. So see, both case I have calculated. So one place we are getting 0.9. This type of question have not asked in GET till now. I think they have asked only average value. So if in question it will be asked across this one, across source point. So source point means constant voltage. Constant voltage we will take the this current. And if they will make arrow here, so in that case this RMS voltage divided by this RMS current. Okay, is it clear? Already I have explained why RMS and why average. I will share this PDF also. Is it clear to all?
Sir, from this R2 is less than R1, sir.
Yes, it will be. See, power only we have to balance it out. 1 second. I will write the power equation. So P is equal to that equivalent resistance should draw same amount of power. Okay, R equivalent. Here, what is the voltage source across that point? Voltage source is a pulse across diode. Not, voltage is not 15, so this is available for 2 by 3 voltage source. Okay, this is voltage. So what will be the power? Power will be V square by R equivalent. Okay. So here voltage RMS how much we are getting? 15 into root 2 by 3. So this square if we divide by 0.6, we will get 250 watt. Okay. That's why equivalent resistance means it should draw same amount of power as load. It should draw 250 watt. Is it clear? Clear to all?
Yes, sir. Yes, sir.
Like in another way also we can do this, like how power is 250 watts. So like let's say this is inductor current. So the first case I am telling. So inductor current is how much? This is 23, this is 27. Okay. And what is the voltage? Voltage is constant. So power waveform we can draw here. What is the power waveform? Power is the voltage into current. So voltage, this is 15 volt constant. This is the current. Okay. This is source current. So power we can see here some minimum and maximum value will come. Okay. This is how much? 15 into 23. Can anyone tell how much? This will be I think 345. And maximum will be 405. Okay. And this is total time period. So P is equal to how? 1 by T into VI dt. Okay. So we can say that 1 by T into area. It clear? So this is 4 microsecond. From here to here, it is 4 microsecond. And this how much? From 405 minus 345, how much? This is 60. Okay. So time period, how much? Total 6. So 1 by 6 micro, 1 by 6 micro into area of this rectangle, how much? Can anyone tell? 345 into 4, no? So 345 into 4 plus this triangle 1 by 2 into 4 into 60. So finally, if we'll calculate this is micro and here also it is micro. So micro will cancel. Final will be 250 watt. Can anyone calculate and verify this one?
Yes, sir. I think it's right.
Yes. So like how we are calculating power, this is the main formula. So three concepts we have learned today. This is the main average power formula. And if any one will be constant, what we will take? We will take the average of the another. If both will be constant, we will take the RMS of the both. It clear? Okay.
Yes, sir.
So more questions are there. If time will be there, I will discuss. If otherwise,
Sir,
we can.
a question
In
in the
yes.
first circuit in this circuit,
Okay.
if the supply source supply portion is disconnected,
Okay.
then what will be the freewheeling diode current?
See, this will be disconnected means. 1 second. I will take to this to another case. 1 second. One second. Okay. So when this switch will be on, okay, in that case, this current will flow like this one. It will flow like this one. Okay.
Yes, sir.
When
Yes,
switch
sir.
will be open, so inductor current will be there. That will flow through this path.
Okay.
This diode will conduct. When switch will be disconnected, like this will be off, then that case the diode will conduct. Is it clear or any other doubt is there?
Sir, I said that when the switch is on, that
Okay.
means it flows current from uh, inductor load and the capacitor will charged.
Yes.
After when the switch is off, the switch is S1 is off,
Yes.
then the diode works like a free wheel diode,
Yes. Yes.
and it takes current from inductor and capacitor and
Yes.
flows to
So
the
same
circuit.
inductor current will IL will flow through this one. Okay. This diode will. So what will be the diode current? Diode current will be the second half current. Inductor current will be charging. So discharging current will flow through diode. This will be the diode current. Okay. In second half, this will be the current. This will flow through this diode. This will flow this diode like this one.
Yes, sir.
Is it clear? Okay.
Okay, sir.
Okay. So I will share the PDF also in the group. All of you are there in the group.
Sir, in that also there will be
Group.
diode resistance, sir.
Which diode resistance? This all for ideal condition. I'm telling. Not a non-ideal.
Okay, okay.
Non-ideal means all the volt second balance analysis will be different. Like if diode resistance we are considering, that will be more complex kind of equation. That normal equation will not work there.
Okay, okay, sir.
Okay, how can we get access to that group?
1 second. If like chat box, you can write your mail.
Wait.
Not
With
mail.
phone number?
Mobile number. Mobile number. Yes. Write the mobile number.
But sir, sir, we are not in that group, sir, because
Okay.
we have given number.
Okay. Okay. I will tell them to it. Again, you can write your number here. I will again resend them. 1 second.
Sir, in this circuit, when the inductor will discharge, it will not dissipate uh, it will not dissipate the power as a heat
See,
in the resistor.
inductor is like ideal inductor we are considering, but load power will be dissipated in this load. Load will draw the power. Only resistive part will draw the power. Remaining inductor and capacitor will transfer energy between them.
Yes, sir.
Charging and discharging will happen periodically. It clear?
Okay, sir.
Okay, so thank you all. Hope all of you got some new thing today.
Thank you so
Uh,
much, sir.
Sir, could you please put this link of this PDF in the chat box?
PDF I will share in the group. There I will all of you will be added. There only I will share.
So can you share the WhatsApp invitation link?
I will tell admin all of you will be added. Those who have shared the here number, I will tell them to add.
Okay, okay.
Okay. So thank you all. Next Monday also I will come with some good concept, new concept. I will try to know something new. Already more things are available on YouTube, but I will try to clear some basic concepts. Okay. So thank you all. We'll meet in the next session next
Okay,
Monday.
sir.
Thank you.
Thank you, sir.
Sir,
Okay, if some personal query also will be there, like somewhere you are, all of you will be facing difficulty, like some common topic will be there, that I will also discuss if that kind of thing will be there. Like it's some topic if you are facing difficulty in power electronics, like three-phase rectifier, most of the people are facing difficulties like waveform analysis and all. In those survey I will take in the group. If everyone will be interested, I will take session on those topics.
sure, sir.
Okay. Thank you
Yes,
all.
sir.
We'll meet on the next Monday. Thank you.
Thank you, sir.
Thank you, sir.